Hello friends, this is Devbrata Pramanik and you are watching my channel Physics Friends. Today we are going to find out the electric field of a dipole. We have considered a dipole of dipole moment P and we are going to find its electric field at 2 points, namely A and B, where A is an axial point and B is on its perpendicular bisector plane. Now look at the figure. First we will find the field at an axial point, that is at A. Two equal and opposite charges plus q and minus q separated by a very small distance d constitutes a dipole of dipole moment P is equal to qd. Now plus q charge is at a distance r minus d by 2, whereas minus q charge is at a distance r plus d by 2 from the field point A. So plus q charge produces an electric field at A along this direction and minus q charge produces a field at A along this direction, that is attractive one. So total electric field at A due to this dipole would be like this. This term comes from plus q charge, as plus q charge is at a distance r minus d by 2 from A, and this term comes from the minus q charge contribution. In the next step we take r outside the bracket, so the outside term takes the form q by 4 pi epsilon naught r square, whereas the terms within the bracket looks like this. But look at this term d by r, especially d by r. D is very small. It is of molecular dimension, is of the order of angstrom, whereas r is the distance of the field point. So r is very large than d. So d by r is very small. So d by 2r is very much smaller than 1. So that these two break this expression, we can happily use binomial expansion relation like this one. 1 plus x to the power m is almost equal to 1 plus mx, where x is very much smaller than 1, like this one. So we can happily use this binomial expansion and ultimately we get like this, where 1 and minus 1 cancels out, and finally we get A as twice qd by 4 pi epsilon naught r cube. But qd is the dipole moment P, so we have twice P by 4 pi epsilon naught r cube field at A. Actually the electric field at A is along this direction, so we take the vector notation here. So A is along this direction, that is along this dipole moment. Next, now we will find out the electric field produced by P at this point, which is on the perpendicular bisector plane. Like before, here also we will consider the two fields produced by the two charges separately. At B, plus q and minus q produces same magnitude field along this direction and this direction. This one is formed by plus q and this one is formed by minus q, and this electric field is nothing but q by 4 pi epsilon naught this distance this distance square. But what about this distance square? This is nothing but r square plus d by 2 whole square, that is r square plus d square by 4. So E is equal to q by 4 pi epsilon naught r square plus d square by 4. But this 2E has equal inclination theta with P. So we have the resultant field at B as 2 e cos theta, as the E sin theta terms for this along this direction and for this E along this direction cancels out. So the total resultant field at B due to this dipole would be 2 e cos theta. This term is E and this term is cos theta. Look at the figure. This angle is theta, so cos theta is equal to d by 2 divided by this distance, which is equal to r square plus d square by r to the power half. So ultimately we get this term. But d square by 4 is very small compared to r square, so we can neglect it. Finally we get qd by 4 by epsilon naught r cube. But qd is nothing but the dipole moment p, so ultimately we get the field at B is equal to P by 4 pi epsilon naught r cube. But look at the direction here. Resultant field is along this direction, whereas dipole moment along this direction. So it is opposite to the dipole moment. So we must take a minus sign. So finally we get the electric field at B as minus P by 4 pi epsilon naught r cube. Here this is along this direction minus P and its magnitude is minus P by 4 by epsilon r cube, whereas at this point we have this field twice P by 4 by epsilon r cube. Here twice P by 4 pi epsilon r cube, and here minus P by 4 pi epsilon r cube. Thank you.